Hello guys, welcome back. This is fourth video in the LlamaIndex series. The first two videos were about how to deal with the unstructured data, and the third video was about the structured data. And if you go to the LlamaIndex documentation also, as you can see here, the unstructured data were PDFs and videos, images. So we deal with the PDFs, and the structured data was SQL and actual kind of things, but we deal with the SQL. But let's create a scenario where you need to deal with both of these structured as well as the unstructured data. How to achieve that? In this video, we are going to deal with this. And for that, there is a SQL auto vector query engine in LlamaIndex. How it works in high level, as you can see in the figure, let's say that we ask a question, tell me about the arts and cultures of the city with the highest population, right? So what it does first is it hits the selector, and the selector identifies, or it tells whether the question needs to be go to the SQL query engine or it needs to be into the vector database. If it goes to the SQL query engine and it finds that, okay, what is the name of the city, and then there is a query transformation happening. If the answer is already found from the SQL engine, it provides us the answer. Otherwise, it goes through the query transformation phase by the answer that it got from the SQL query engine, and the new query will be then passed into the vector DB query engine, and then we get the answer out of it, meaning that the original question, the SQL query, SQL response, vector store query, and the vector store response are combined into the prompt in order to synthesize the final answer. As you can see, there are many steps happening, but this is really good query engine from LlamaIndex to solve the problem that we have, that we need to query into two different places in order to get the answer. Now let's get into the coding part. The first thing first, we need to set up the environment, right? I am going to install the necessary things. By the way, I will provide the link of this notebook in the description of this video. We are installing the LlamaIndex, OpenAI, and Pinecone client because we are going to use Pinecone. And by the way, if you are new to Pinecone, the last video, not the last one, the second video, I have explained you chat with documents with Pinecone as vector store. So refer to this in order to get the in-depth information about how to do with the Pinecone. Okay, so now our packages is being installed, and we need to provide the OpenAI API key because we are going to use the models from OpenAI. For that, we need to go to the particular URL. You need to click this and it will lead you to this page. We need to create the secret key. I will create here. I can just pass the name here. Let's say LlamaIndex, and I will say create secret key. I'm going to revoke or delete this after this video. So you don't need to mention in the comment section, okay, my API key is being exposed. So what I need to do here is just go here, delete this, and Control V. So if I run this, now I'm providing the OpenAI API key. What is the next step? Here is the next step. We are going to import the necessary modules from the LlamaIndex, and that's all. Nothing to explain more here. So we are going to create the common objects now. So what is the common objects? If you expand this, the first thing we need to create the index in the Pinecone. I have explained, as I said you before in my second video, in depth how to deal with that. But for that, you need to have an account in app.pinecone.io. Please create the account there. And this is my signed in Pinecone website. And here I have the index. There is no index, but I need to get the API key from here. We are not going to click here and there in the UI itself. We are going to create all the things from the code itself. So for that, we need to get the API key. After you get signed in, you can go to this API key, and there is the environment, and this is the API key. I will copy the API key, and I will go here, and in the place of Pinecone API key, I'm going to paste it. And again, I'm going to revoke this once I create the video. And this Asia Southeast 1 GCP, I just get it, which is mentioned here. That is the environment. So when we pass this, then there is the initialize the connection to the Pinecone. So this is the code that you need to run. And once this is done, it will create an index named quick start with the dimension 1536 because we are using the OpenAI API key and that embeddings needs to be used there. The text embedding out of 002. Metric, you can choose Euclidean or cosine, whatever you want to go through. I'm choosing the Euclidean here and port type E1. You don't need to provide this, but this is what I have been providing and I'm taking the code from documentation. This is what it is shown there. Now, as you can see here, if I go to the index, there isn't anything being created. But if I refresh the page now, there is the quick start index being created. And now the cell must be completed successfully. Next thing, I can just say, okay, Pinecone list indexes. There is a quick start, which we just seen here, quick start, right? So I can say describe this. It will just show us more information about it, all the metrics that it is being used, replicas, dimension, and all the different things if you need. And what we can do now is connect to the index. For that, what we can pass is we can say, okay, Pinecone index is pinecone.index, and we take that particular index so that we can pass it into the code. So next thing here, this is the normal things that I'm importing from LlamaIndex, of course, but different modules. And here we define the node parser and the LLM. By default, LlamaIndex uses some model from OpenAI. But if you want to provide your own, you can provide that into the service context. That is what I'm doing here. I'm providing the chunk size of 1024 and LLM, I'm taking the OpenAI and I'm taking the model GPT 3.5 Turbo. I'm passing these things into the service context. So here, this is the service context dot from defaults. I'm passing the chunk size as well as the LLM. And I'm saying the text splitter and node parser. And then I'm defining the Pinecone vector index. As you can see here, this is the Pinecone vector store. We pass that particular index which we just created here. And then we give the name space. It's optional, but we can give it as wiki cities because we are going to extract some text information from Wikipedia. So yeah, I'm creating the storage context and there is the vector store. I can just run this particular shell. So all the things will be done here and that's already done. So what is the next step? We need to create the database schema as well as we need to pass some test data. If you just expand this, so again, we are taking the SQL Alchemy, we are importing some of the things. By the way, if you want to know more things about this SQL Alchemy, I have used the DocDB before. The steps are almost the same. So you can refer to that because we are using the text to SQL as well as the semantic sorts. So both of the things which I have mentioned in video 3 and video 1 and 2 are of course in this video. If you watch previous, it will be easier for you, but it's not mandatory. So we are going to create the engine using the SQLite in this case. So in memory, and that's how we create it. And we need to create the SQL table. So how to do that? We can just name the SQL things. Okay, this is the city stats table. There is a table being created. You can pass different columns as it is mentioned here, and then we will create the engine. If you want to print something, you can just print the table. Okay, we have the city stats. Once that is done, what we need to do is we need to introduce some test data into it. This is just the test data being executed in that particular table. Once that is done, you can select all from this. It will show us, okay, there is 3 rows with the 3 columns. So we have the city name, population, and the country. So we can see here. Now that is done in the place of SQL to text kind of things. So that means that one part is done. Now we need to do the next part, meaning that we need to take something from somewhere and put that into the vector store. For that, what I'm going to do is use the Wikipedia loader from Llama Hub. By the way, if you don't know what is Llama Hub, there are different loaders as well as different tools. So I'm using the Wikipedia tool and it is shown here how we can use this. But if you go to the home icon here, you can just sort whatever you want and you can add a tool also if you want, and you can sort by popular or recently added, and you can find many things here. and I'm going to use the Wikipedia. So meaning that I need to install the Wikipedia library. So I'm installing this here. And by the way, if you are thinking what this percentage capture does, I have explained in each and every video that it captures all the jargons that is printed when we install something. So it's clean notebook. Okay, so after you install the Wikipedia, then you just run this particular cell. You can just run this. So what it is doing here, as I said you before, it is taking the from LlamaIndex, importing download loader, and we are using the Wikipedia loader, right? So once this is done, I can say, okay, what is the length of the wiki docs? There are 3 different docs because we are taking 3 different cities: Toronto, Berlin, and Tokyo. What we do after this is we need to create the SQL index as well as the vector index for 2 different things, right? Let's go and create the SQL index. So here I'm just providing this SQL database, and from LlamaIndex I'm importing this NL SQL table query engine, and then I'm just passing this into this. I'm creating the SQL index. Similarly, now I need to create the vector index. So this is the line of code that I can just run in order to insert the documents into the vector index. So once this is done, as you can see, it says offsorted vectors. So it is offsorting the vector 17, 17, 18, 18, 11, 11, meaning that there are different nodes being created, as you can see here, and that needs to be uploaded into our Pinecone. If I go to the Pinecone website, if I go inside this now, so let's refresh. As you can see here, there is some data here, meaning that now our embeddings are being uploaded into the Pinecone. So we can extract the information out of it. Here it says define query engine set as tools. So we have now 2 different things. We need to now define the query engine in order to get the information out of it, right? For that, we first import the necessary modules. And here, as you can see, there is this vector store info. So we have vector store info, articles about different cities. We just give some content info and some metadata. So metadata, we are giving the name as the title, type is string, and description is the name of the city. And now we need to pass into this. There is vector auto retriever. So we are just retrieving the information. So retriever query engine, and I'm saying here retriever query engine dot from args, and I'm passing the vector auto retriever, which it is here, and then the service context we have created up here. Let me scroll. Here is the service context. If you don't pass this, the default model is being used, but we want to use the GPT 3.5 Turbo. If you don't want, you can just leave it, and the default one will be used. What I can do now is just run this piece of code. It is going to create what it is mentioned here. And then now let's create the SQL tool. How to create the SQL tool? Query engine tool dot from defaults. We need to pass the SQL query engine we created, and this is just the description that we are providing for this, as well as the vector tool, and we are passing some description into it. This is how we create the 2 different tools, and we need to pass now these 2 different tools into the SQL auto vector query engine. So how to do that? As you can see, this is just simple piece of code. We have the query engine, and we need to pass that 2 tools. So SQL tool, vector tool, which we just created here, and the service context, as I said, because we want to use that particular model. If I just run this, now we are ready to query. There were many steps here, but if you follow this notebook, you will know what is the idea along with this video. So now we just do the query. As I said you before, when we do the query, all the different things are passed as a prompt into the LLM, and we get the answer out of it. Now what I will do here, if you go to the image up here, so we have this selector. When we ask some question, the selector selector tells us either to go to the SQL query engine or into the vector database. I will show you 3 different questions. One which goes into the SQL query engine and gets answer out of it. Second one which goes into the vector DB. So selector says that okay, it needs to go into the vector database. And the third one will be that the selector says that okay, it needs to go to the SQL query engine, but the answer is not there. So it also needs to go to the vector DB, and the query transformation happens, and then we get the answer out of it. Let's go into it. Let's ask the first question. So first question is, can you give me the country corresponding to each city? If I just run this, So what is happening here is this information can be just achieved from the SQL database, right? I just want to have the country corresponding to each city. As you can see here, it is saying querying SQL database. So the selector says that, okay, it needs to go into the SQL database. The first choice is most relevant because it mentions translating a natural language query into the SQL query, right? So it says here SQL query. So select city name country from city stats and the response is given here. So the final answer is the country corresponding to each city is Canada for Toronto, Japan for Tokyo, and Germany for Berlin. So if I just want to see what is the metadata also, I can just go here. As you can see here in metadata, it just shows us the SQL query and the result. Okay, that is one question. Now let's just ask a question where the SQL database is not even needed. Tell me about the history of Berlin. If I want to know the history of Berlin, then it can go into the vector DB and source the answer for me, right? So yeah, it says here querying other query engine apart from the SQL database. The question is asking for information about the history of a city, which is related to answering from the semantic questions. As you can see here, it just went here and find the answer for us. So Berlin has a race, diverse, this. If I just go here and see the metadata, it will show us, okay, it searches these two different nodes and find the answer for us. That is how it works. Now let's ask the question where both of these things needs to be used. So tell me about the art and culture of the city with the highest population. I haven't mentioned here which city, so it needs to first go into the SQL database and then just find the answer for us, right? Let's see what happens now. Remember that we are using GPT 3.5 Turbo model, right? So it says you're querying SQL database and the first choice is relevant because it mentions translating a natural language query into SQL and it goes into the SQL things which it went like before. And then there is the answer. So if I just go here and print the response, okay, it finds the answer. But if you notice here something, where is the query transformation happening, right? So here is some kind of cheating being done because it it just goes to the SQL database and it knows that it needs to find the Tokyo. So it gets the Tokyo. And instead of going into the vector DB, it just provide the answer, meaning that LLM did some cheating here. And I did some investigation why this is happening. And I find that the model is the issue here because GPT 3.5 Turbo is not able to do the query transformation and go to the vector DB. Instead of doing that, it is providing the answer by itself. So that is the main thing in LLMs that you need to test with different models. I was also wondering before, okay, what is happening here? But then what I noticed here is let's use GPT-4. Then what happens, right? How to do that? As I said you before also, there is a service context. If we provide that into the LlamaIndex query engine, it uses that, right? I use the LLM OpenAI temperature 0 model GPT-4. By the way, you need to have access to GPT-4 from the OpenAI API. I just pass the service context into the service context and I pass that into the SQL vector auto vector query engine. And as you can see here, this is the same SQL tool and the vector tool, but the service context now uses the GPT-4 model. So I need to create again this query engine. And now let's ask the same question. We ask, tell me about the arts and culture of the city with the highest population. So this is the same question. Now let's see what happens with the GPT-4 model, right? It needs to first go into the SQL database and then to the vector database. So it is going behind the scenes. Let's hope it prints something. Okay. It says querying SQL database, the first choice. I don't need to go through this. It will now query the SQL things. Okay, SQL query. As you can see here, it still says that, okay, population SQL things from this SQL response, the city. Okay, it still cheats. With GPT-4 also, it seems that it is cheating. Okay, I did some testing here. So what I did here was just played around the different temperatures because before I was using temperature 0.0. So I tried with different temperatures because I was just first going to the temperature, and then I was planning to go with the other parameters also. But when I increase the temperature to 0.7 and when I use the GPT-4, it provides the answer. As you can see here, first it went to the SQL database and it finds some SQL response. The city with the highest population is Tokyo, Japan, right? And then what it does here is transform the query given SQL response. So it says here, can you provide more information on the arts, festivals, and events that Tokyo hosts throughout the year? So it did the query transformation and it creates the new query, and that is then passed into the vector database, and the final answer is being provided for us. So if I just print the final answer now, so yeah, the city with the highest population is this. And if I want to know now that if it gets the information from vector database or it just get from normal LLM's knowledge base, if I do the response.metadata, okay, as you can see here, first it uses the SQL database, and then there is these two different nodes that is being used from the vector DB, which shows that okay, it went into the vector DB as well as the SQL database and finds the answer for us. And if you want to delete the pinecone index, now let's say that you don't want to use that anymore, you can just run this command which deletes the index that was being created in the pinecone. So when this is deleted, what is the conclusion that we can make here? Chunking plays a vital role. Although I didn't show you the chunking part, that is the key thing that you need to play around with the chunk size, overlapping chunks and so on, and need to play around with the different models to get the right answer. As I showed you, 3.5 does not give the right answer. Well, 3.5 does not give the right answer. I tried with 4 also, but it also didn't give the correct answer sometimes. But then you also need to play around and do the trial and error with different models as well as the default parameters. There are different parameters used in the model. So if you need the right answers, or if you want to have your own kind of use cases, you need to play around with different parameters of the model. So that is the conclusion. And now I hope the pinecone index is being deleted. Let me go to the website. If I refresh the page, it shouldn't be there. Yeah, there isn't the index, meaning that it is now deleted. And one more thing that I want to show you, how much does it cost for me to go through different experiments that I did for this particular video, because that is something that many people does not explain, and many people think that okay, it might cost too much with using OpenAI models. So if you go to this uses section here, as you can see, I haven't used that many of the things, but today is 19 October where I record this video. So as you can see, if I go on top of this, it is using around 20 cents. For embedding model, is it using 0.01, meaning that to get the data from Wikipedia and then sending it into the pinecone, $0.01. And then for GPT 3.5, it costs 0.03. And as you can see here, GPT-4 is a little bit expensive. It costs around 0.16. So the total cost using the OpenAI model is 0.2 cents US dollar. So yeah, I hope now you get the idea how much it will cost in order to experiment something. So yeah, that's all for this video. I hope you learned now how to deal with the use cases where you might query two different things. One is the SQL database as well as next from the vector database. Thank you for watching and see you in the next video.